Welcome back, everyone. Today we're going to be talking about the Cartesian coordinate plane and distance formula. Most of this video will deal with just coordinate points on the Cartesian coordinate plane, which was established by René Descartes back in the 17th century. He used it to bridge the gap between algebra and geometry because on the Cartesian plane you can represent curves and shapes with algebraic functions, with equations. And use that to solve problems algebraically. Now, the Cartesian plane is what you might know is just the normal like xy. It's the xy plane. The x being the horizontal number line, and y being the vertical one. So this is the x. This is the y. The coordinate plane is the intersection of two number lines, one horizontal, one vertical. It's called a plane because in math, a plane is essentially just a flat sheet, if you want to think of it like that, with no width that can extend forever. It has a length and a width, but those are the only really two defining factors of it. It just goes on forever. It's a big flat open sheet that goes on forever. So this would fit a plane. Like I said, it's the perpendicular intersection of two number lines, one vertical, one horizontal, because it has to maintain that 90 degrees. The Cartesian plane is also given quadrants. And if you start in the top right corner, which they start there because that's where both x values and y values are positive. And normally, that's where you start learning numbers. You just start with the positive integers or the positive numbers, and you go work from there. But the quadrants count around in kind of a weird way. It goes from 1 to 2 to 3 to 4 around in a counterclockwise direction, starting from quadrant number 1 in the positives, like the positive number zone. And it goes around from there. Because up in quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, both are negative. And in quadrant 4, x is positive and y is negative. And that's what defines those quadrants. Okay, and in terms of, so when we start the first problem, in terms of coordinate pairs here, we're just talking about what the points are on the Cartesian plane, and you list them in terms of x first and then in terms of y. So let's go through these. We'll go around and we will list all of, or we'll find all of these points. Okay. So here we can see that point A, you always start in terms of x and then go in terms of y. Well, in terms of x, we start at the origin, and the origin is where the intersection of both number lines, where both are equal to 0. That's the 0, 0 point. That's called the origin. And that would be the center point. So we know that J is 0, 0. It's the origin. That means you don't go, you go 0 in terms of x. You go 0 units in terms of x, and you go 0 units in terms of y. And going in order from there, for A, we can see we go 0 units in terms of x. We don't go horizontally at all, but we go up vertically 9 units. So this point would be considered 0, 9. That'd be A. For B, it's really similar. You don't go horizontally, you only go vertically. You're on the y-axis, as it's called. This is the y-axis up here. That's the vertical axis. The x-axis is the horizontal axis. So you don't go anywhere on the horizontal axis, you just go vertically. So this point would be 0, 8. Now for C, we see that we go over to the left 1, 2, 3, 4 units, and then we go up 7 units. So the way we'd say that is -4, +7. We go to the left 4 and then up 7. And that's important to note too. It's standard on any Cartesian plane, on just on the Cartesian plane in general. If you're going to the right of the origin, or if you're going to the right, you're adding, or and if you go to the right of the origin, it's positive. Whereas if you go to the left, you're subtracting. And also, if you go to the left of the origin in either the x or y axis, it's denoted as negative, the negative numbers. So that's important to note too. Okay, so moving on for D, we don't go anywhere anywhere on the horizontal. We don't go anywhere on the horizontal axis. We're on the vertical axis. So the x value would be 0, and then we go up 5. So the coordinate point of D would be 0, 5 for D. For E, we go over 1, 2, and then up 5. So we start by going over 2 and then go up 5. Now for F, we go to the right 1 and then up 2. So it'd be 1, 2. That would be the coordinate point, or the coordinate pair. And that's how that point is denoted in 2 dimensions. Okay, where is G? I might have to go down a little bit now. Yep, okay. Don't have to come back, okay. Don't have to come back up there for too much more, I don't think. Okay, so for G, notice we go over 2, but we go down 8. So just like horizontally, if you go to the right, you're adding or going to the going toward the positive direction. If you go and when you go left, you're either subtracting, or if you're beyond the origin, you're going the negative numbers, the negative direction. Well, for the y-axis, it's the vertical one. So if you're going up, you're either adding, or if you're going up beyond the origin, it's the positive direction. If you're going down, you're going in the negative direction. So this would be, G would be represented by 2, -8. H, to start off with, we go over to the left 8 and then up 2. So it'd be -8, +2. And as you can see, we kind of just switched the positive and negative from G. We go over to the left 8, up 2, and you always list the x coordinate first. I, you're on the x-axis, so you go over 5, but you don't go up at all. So you stay on the x-axis. So it'd be 5, 0, because you don't go up any or down any. J, as we already discussed, is the origin. It's 0, 0. That's the middle of that's the intersection point of the 2 number lines. That's the middle, the very center of the plane. Okay, and then K, we can see we go to the left 1 and then down 2. So it'd be -1, -2. L, we can see we go to the right 5 and then down 3. So it'd be 5, -3. M, we can see we go to the left 6 and then down 4. So it'd be -6, -4. And then N, we can see we go to the left 4 and then down 6. So it'd be -4, -6. And then O, which I believe is the last point, we go to the right 1, but then down 7. So it'd be 1, -7. So we can see all the points be labeled. And now the next questions will be dealing with the quadrants. So keep them in mind. Remember, we start in the left and we go around counterclockwise to count up the quadrants. Okay, so the following point is in quadrant 1, -1, 2. That's a true, all of the next ones are true or false questions. We have to evaluate that for ourselves. So real quick, I'm gonna give us another coordinate plane to work with for all the next questions. Oops, that's not what I wanted to do. Okay. Let's get that stray mark out of there. And we'll put a few. There's just mean that it goes, it goes on forever in those directions, or in all the directions. I just want to put a few tick marks on here. All of those tick marks denote counting 1 in that direction. It's either not the best, it's just kind of a rough idea to see. And just as we can, or just for a reminder as well, this is quadrant 1, 2, 3, and 4. Okay, so now the following point is in quadrant 1, -1, 2. Okay, so if we plot that point, if you saw what we did in the last time, we're going to go, if it's -1, 2, -1 means, and when you plot points, you always start at the origin and you count from there. The origin's like the center, it's the base almost, if you will. That's where you start everything. And that's what you compare everything to. So we have -1, 2. So we're going to go to the left 1 and then up 2. So this would be our, my goodness. Oh my goodness, I don't know why it doesn't want to let me do this point. Anyway, that would be where we are. Try this on for size. There we go. That's a little better. Okay, so that one is actually in quadrant 2. So we know that that statement is false. Okay, the following point is in quadrant 3, -2, -4. Okay, so same type of thing. If we do -2, -4, we're going to go to the left 2 and then down 4. So we actually are in quadrant 3 for that one. So this one is true. Okay, for number 4, the following point is on the y-axis, -2, 0. Well, in terms of this one, -2, 0, -2 is an x value, because that's what we start with. We go to the left 2 and then up 0. So it would actually be on the x-axis. So this one is false. It'd be on the x-axis. The following point is in quadrant 4, -1, -8. Well, instead of applying this one, we can see too, did you notice how in the one where there were both negatives, it was in quadrant 3? And you know how I said up here, quadrant 1 represents when the x and y values are positive. Quadrant 2 represents when the x value is negative, y value is positive. Quadrant 3 is when both of the x and y values are negative. And quadrant 4 is when the x value is positive but the y value is negative. Because if you notice, for quadrant 3, if both of them are negative, you're going to go to the left and then down. So you'll end up in quadrant 3. Quadrant 3. If they were both positive, you go to the right and then up, so you'd end up in quadrant 1. If the x value is negative but the y value is positive, you go to the left first and then up, so you'd end up in quadrant 2. And then the same logic applies for quadrant 4. So rather than plotting the point, if it's just asking what quadrant it's in, we can see that both of these values are negative. So that's going to put us in quadrant 3. So this is false. It should be in quadrant 3. And then it says the following point is in quadrant 2, -5, 3. Well, if we think about it, we're going to the left and then up. So this is true. Because you're going to go to the left 1, 2, 3, 4, 5, and then up 1, 2. So you're going to be in quadrant 2. So this one is true. Okay, the following point is in quadrant 3. 4, -3. Well, all the other ones that were in quadrant 3 had both the x and y values be negative. So this one is false. If we went to the right 4 and then down 3, we'd actually be in quadrant 4 because we'd be going to the right 1, 2, 3, 4, and then down 1, 2, 3. We'd end up in quadrant 4. Okay, and then now we have to find the distance between the 2 points, 5, 8, and -3, -7. Okay, so believe it or not, this is actually really similar to what we did with the Pythagorean theorem because, and let me show you, let me illustrate this out. Okay, so we'll say, I don't know, 5, 8. We're going to go to the right 5, up 8. It's about right there. And then -3, -7, you're going to go over to the left 3 and then down 7. So it's about right there. So what we're doing here, and as we can kind of see, we're essentially doing, we can see that there's a diagonal line between these 2 points. And then from there, we can think about this as there, if we wanted to think about this, if we think about how to get from the bottom point to the top point, other than the diagonal line, in terms of the way we've done Cartesian coordinates, is we go to the right and then up. Sorry, that line wasn't great. And then notice here too, this makes a right triangle. So what we can do now is, now that we know what points these are, this is 5, 8, and this is -3, -7. This just becomes our hypotenuse, our C value. Our C value. The A value would be, to find, sorry, I'm trying to find a good placement for this, and it's just not working out too well for me. There we go, that's better. If we wanted to find this leg, what we'd notice is this is parallel to the x-axis, so we'd find the distance of the this horizontal distance by subtracting 5 and -3. So, or because we're thinking in terms of finding the difference here, the difference in distance. So we'd have 5 minus -3, which is 8. Okay, and then or notice if you did it the other direction, because you could, if you did it in the other direction for one, make sure you do it in the other direction for the other. You could do -3 minus 5 as well, which is -8. But if you're talking in terms of strictly distance, you always would take the absolute value of that value. So the distance is 8 because you can have negative distance. But in the formula, it won't matter because it's getting squared. To find this vertical distance, or this side, we'd have 8 minus -7, which is +15. You could do it in the other direction as well, -7 minus 8. Just keep in mind, if you're talking about distance, you'd express it in terms of the magnitude, or the absolute value of that value, which would be +15. So we can see that 15 is our height, or is one of the legs, and 8 is another one of the legs. So you can use the Pythagorean theorem now to solve for the missing side, or for the distance between these 2 points, or the c value. And by the Pythagorean theorem, we have c squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared. So c then, in this case, is equal to the square root of a and b can be either one. You can interchange them, of 8 squared plus 15 squared. So c here would equal the square root of 64 plus 225. Sorry, these addition signs are not doing it for me today. So we'd get c equals the square root of 289 . So c then would equal 17. That is the distance, 17 units. That's the diagonal distance between these 2 points, between the points we have. And then the formal distance formula is like this, because if you notice these 2 points, we had 5, 8 and 3, -3, -7. Okay, so yeah, we have these 2 points. Now, notice that if you have 2 points, we're going to denote this value as x sub 1, just to note that it's in the first point. And this one would be y. Ooh, that's terrible. This one would be y sub 1. But that does not look like y sub 1. It just looks like terrible handwriting. And then the second one, we could denote the 2 coordinates as x sub 2 and y sub 2. And if you notice that for the legs of the right triangle that we formed by connecting all those points together, or connecting those 2 points together diagonally and then vertically and horizontally, the horizontal leg, we can say this one would be A. We know that that equals x2 minus x1, which would be which we found up there before. And then the vertical leg is just the difference of y, values. So we'll call that one B, and it was y2 minus y1. Okay, and then C is the unknown. That's what we don't know yet. So keeping this in mind, for a generic distance formula, we have a squared plus b squared equals c squared. Well, we know now that a and b are x2 minus x1 and y2 minus y1 respectively. So we have x2 minus x1 quantity squared plus y2 minus y1 quantity squared is equal to c squared. And like we did before, we take the square root of both sides. So we're left with c is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we have what's called the distance formula. And we can use this to solve for the distance between any 2 points on the Cartesian plane. This works for anything because you just do the same thing you did here. You'd plot the 2 points, notice that the distance between them is some kind of diagonal line, and then you can solve for essentially solve for the vertical or for the horizontal and vertical distances that separate the points. Those are the legs of the right triangle. And then and that works too because like if you think about like the coordinate plane on this grid, no matter what, between, there's always going to be a right angle between the vertical and horizontal lines that you form between the 2 points. And so now we can solve for the distance if you think about it in terms of the Pythagorean theorem, like a right triangle problem. And then the hypotenuse will always be the actual distance between the 2 points. And you can solve for that using this system. And that would be the distance formula. And that is it for this video. I hope it was helpful, and I will talk to you in the next one.